I scaled a GPU cloud in a warehouse from 0 GPUs to about 1,000 of them by the time that we closed down. And along the way, I made every mistake in the book. Running that many GPUs or just that many servers in general is very difficult. And I think a ton of people that come into this business, they just look at, okay, what are the costs of the GPUs or the servers? What are the hourly rates that I'm seeing online? And they just divide that totally evenly, right? Cloud computing is so much more than just the hardware. And I think we learned a lot of lessons the hard way. So I want to make a guide so that if anyone's considering, doing something like this or is already doing something like this, maybe we can give you a bit of a 3-year head start here. So the plan is I'm actually going to make 6 videos that cover all of these topics in way more detail. But for the purposes of today, I'm going to give an overview or just a very light guide on how to build an efficient cloud operation for a GPU business. And this holds true for if you're running GPUs for your own company or if you're running GPUs and selling them out into the market. The goal of this is to help you avoid the mistakes that we made that ended up costing us a ton of money in the long run. So hopefully this gives you, a place where you can kind of hit the ground running. First thing we're going to talk about is building and buying GPU servers. So that motherboard that I have behind me there, that is a SlimSAS based motherboard. It's different from a normal motherboard where you've got PCIe slots on it, right? Like if anyone's ever built a gaming PC before, you take GPU, put it in a PCIe slot, and that connects it to the CPU. In a SlimSAS based motherboard, all of the PCIe connectivity runs through SlimSAS ports, and then you're using SlimSAS cables to, fan the connectivity out, right? You can imagine if you take 8 4090s or 8 5090s, you need a lot of space to spread those out around a chassis, or if you're doing open air, you need to, put them on different racks and stuff like that. So SlimSAS is the way to go. There's really one motherboard. Put the name of it somewhere right here. If you're doing duals or if you're doing single socket, there's a different one that I will now put the name right here. And these are both ASRock boards. I think there's some other manufacturers that make them. I think there's some knockoffs of these ASRock boards. But I would just say we wasted so much time trying to avoid going this route, and it was for the worst. If you're going to do it yourself, that is the way to go. And you've got more flexibility, I think, if your plan is to do, standard GPU form factors, like if we're talking about like actual enterprise cards. But then at that point, I would just say, unless you have a ton of experience with this, like buying the GPU servers might only cost you, a 10, 15% margin over building it yourself. And you lose or you introduce a ton of risk in doing it yourself. So like if we're talking about building $100,000 servers, I would just pay the extra 10 grand and get a manufactured one with a warranty from a vendor over trying to build it yourself. I think the advantage of building your own comes if you're gonna do the consumer GPU thing. So that's like 4090s, 5090s, and sort of everything in between. Buying GPU servers, I think the part that everybody has to understand is there's different tiers of vendors, and there's good reason why some of them cost more than others. So like tier 1, think of like Dell, Lenovo, Cisco, HPE. They are servicing the enterprise IT market, right? So like they have services that in all these countries, like across the world, where they can have parts on site in 4 hours, and they've got 24/7, support lines set up to orchestrate all this, massive supply chains, so they can get things when things are scarce, and they charge a premium because that service is very valuable to large enterprise. So if you're thinking of buying, hardware to run yourself and you want to, maintain things yourself, they are going to look more expensive than if you were to go and buy something from like a Supermicro, who's going to just, give you like a basic parts warranty on the hardware. And, if something breaks, you typically have to ship it back to them. They'll fix it and they'll send it back to you. So it's sort of like, different levels there. And then there's sort of a third tier underneath all that, where you've got like lesser known, just simple hardware manufacturers like Gigabyte, Asus, ASRock. There's one called Avariz that makes like a good H200, B200 node. These are just equipment manufacturers that can assemble a very reliable server. They have a good warranty. They have support engineers, but they're not going above and beyond. They don't have multi-decade track records of providing like that top tier service. So that's why they're cheaper. But I think that actually is an advantage in a lot of cases for people who are DIYing this stuff, because you can save a lot of money up front. So that's the hardware. I want to talk about the data centers next. So you can either build your own data center. So that's kind of what we did. We rented a warehouse that had a lot of power in it. We basically fanned that power out through the warehouse and then connected that directly to machines. And, for better or for worse, we saved a lot of money, but that, there was no scaling the business after a certain point because of that. Your other option is obviously renting colocation space where, you're in a certified facility. It's got all of the reliability and redundancy in it that you'd expect, and you just sort of pay for what you use. I think the decision comes back down to actually what class of machine you're planning on running. So if you're doing, $400,000 B200 nodes, and you put 2 of them in each rack, and you're paying like a certain dollar per kilowatt or something like that, it's actually a very good deal to just put them in a tier 3 facility, because they actually need to be in a tier 3 facility for the kind of customers that rent those things. And you building your own tier 3 facility, there's just sort of a certain amount of fixed cost in that doesn't work at a small scale. It's when you're doing very high power GPUs that demand low prices, like the consumer 4090s, 5090s, that it's almost necessary to build your own facility. I would just say that the things that are important are at the high end, if you can build it in a way that allows you to get data center certifications for it, SOC 2, ISO 27001, those are all things that are valuable or valued in the market. So that's sort of the best that you can do there. But on the low end, it's okay, you need the power, you need the cooling. You can do a lot of free cooling by just ejecting heat out of the building. And the next step up from that is basically, do you do UPS or no UPS? So UPS is batteries, if you're not familiar. And, you can pay for sort of in-rack UPS. You can put UPS sort of a bigger UPS for the whole facility. Last time I checked, it cost you about $500 a kilowatt to do that. So if you're doing a 200 kilowatt facility, it's going to cost you another $100,000 just to get the batteries in there. And that gives you that 15 minutes of buffer power if there's a power blip. It protects your infrastructure if there's a power surge. So if you don't do that and then a power surge goes through the facility, it can actually destroy equipment. So you do have to kind of consider all of those things. And then obviously the facility you pick, make sure you can get dedicated internet lines put into it. And that's different than just my local provider can hook up a 1 gig connection. You need to make sure that somebody can give you an actual dedicated BGP enabled line into your data center. And ideally you can have 2 different providers do that. And then what you're going to do is load balance and, make redundant connections across the 2 providers. That's a good segue into the next topic, which is actually the network design. So in our data center, we did a fairly simple design, but I think it's really common in a lot of IT environments. It's basically just we had 2 redundant routers. That's where the BGP links would come in from the internet providers. We would we'd have all our public IP addresses assigned there, and we'd actually just assign those public IP addresses directly to the machines. So those subnets were made available across our LAN, and then those IPs were essentially just put right on the interfaces on the servers. In terms of the switching from there, so you've got 2 routers at the top. We'd had 200 gig aggregation switches below that, and they would connect out to pairs of Arista switches in the racks. So we could buy a pair of Arista 10 gig, 48 port 10 gig switches for $200 each or something like that. And we'd put pairs of those sort of in each of the pods and then connect all the machines to those. And then from there, all of the traffic would get backhauled to those aggregation switches. So we had really, really fast links between everything in the data center And then we had, 10 gig WAN going into those routers that was serviced, between those aggregation switches and the routers. At a high level, that's how it worked. The keyword or the technology that makes the switches redundant is called an MC lag. I think it stands for like a multi-chassis lag. Basically just means that if one of those switches were to fail, traffic could still go to the machines because it could just run over the other one. And that was huge because we did have switches fail. We had to update switches. We had to debug stuff. And just having the ability to always have 2 of each thing, that was really, really important for us. That's like your physical facility, right? I think everything up to this point, that's what goes into it. That's how we eventually built it. But until we got there, we were, I had a couple switches just daisy chained off each other. We just had 1 gig links to single ports on each of the machines. There's a real lack of redundancy in it, and we just kept getting burned, right? Something would happen and everything would go offline, and then you lose all your customers and you're back to square one. So if I was to redo it today, I don't think I would build servers. I think I would buy used enterprise stuff like H100s or H200s that are getting decommed. And I think I would build a DIY facility that I could get one of the bigger data center certifications on. So I would still try to save the money and do the DIY because renting facility is really expensive right now. But I definitely wouldn't skew towards that data center warehouse anymore. The next piece is obviously after you've got your physical environment set up, you need some kind of efficient operations. So you can't run around with a USB stick and install Ubuntu on your GPU server and then tell somebody what, the SSH and the password is. We literally used to do that, and it's just way too much to manage. So you need to introduce some kind of PXE-enabled or PXE-enabled deployment engine into the environment. And the one we used was called MAS, Metal as a Service. We ended up working eventually with a company called HydraHost that had a similar, they called it a DCIM, Data Center Infrastructure Manager. And essentially what that did was that plugged into our network and allowed us to boot and install operating systems over the network onto the machines. And so say a machine's doing something and I want to reinstall its OS or wipe it, I just click a couple buttons, it reboots, and the installer starts running and does its thing, right? So, over the course of the years with those, 100 or so servers we had, probably did thousands of OS installations, right? And if the plan was to do that manually, that would have just been an insane amount of, human capital and way too much room for error. So step one is you need to get a DCIM in there. After that, I think, the step above that is you put something more sort of cloud focused in there. So HydraHost, their portal, acts as a cloud interface where they're able to rent your machines through it. They have access to it and help, bring customers to you through it. And so they've kind of integrated a billing component into their DCIM, which goes obviously beyond where Metal as a Service would. We were still obviously interfacing with our customers and using that as an internal tool. And then most of the big clouds, so any of the big providers that are building their own bare metal cloud platform, they use something called OpenStack Ironic. And that's basically just a cloud operations tool, from OpenStack, which is a broader open source cloud ecosystem. That basically, it handles all the PXE for the servers, and then it has all of the, interfaces and tracking and everything that you would need to run a proper cloud. Those are kind of your options there. I'm sure there's, tons more, but I came across those the most while I did this. And beyond that, I think just any IT monitoring software, I think everybody's got an opinion on this. I think it depends who's doing the technical work, but yeah, you need to be monitoring your network. You need to have alerts set up for, if things fail. So I would just say those are all good. And that's something that we didn't have a ton of, but the little bit that we did have, we relied on a ton. And it's your single source of truth, right? You can't be hearing that there's problems from your customers. You ideally want to find those problems and solve them before you hear about it, right? The next thing is your rentals. So this is probably the part that is the most important, and learn this the hard way. And I think that the TLDR is that there's platforms like Vast and RunPod, Shadeform, like other rental platforms where basically you give them the hardware or you provide your hardware to their network, and then they go out and they've got customers that consume it. And they take, a 25% commission in a lot of cases. I know Shadeform takes less, but they're doing, much bigger sort of enterprise stuff. We started on Vast, and, our whole thing for a long time was like, oh man, like Vast is taking 25%. But when you think about like not having to do any marketing, not having to do any sales, not having to do any support, 25% is really cheap. You got to know, like, if something breaks at 2 a.m, like who's answering the phone, right? Like somebody has to. You've got global customers that are awake at all hours. It's really easy to take for granted how much value you get out of just, building the hardware, having a stable facility, and, letting the performance of it just sort of market itself. It lets you just kind of focus on, doing the busy work in the business, and then all of that growth and everything that comes from, the efforts that they've built with their platform, like you get to just inherit that. So I'd recommend for anybody who's just starting with this kind of thing, go to one of those platforms, optimize your earnings, on those platforms, and just know that marketing, sales, and support, like those are all things that require a lot of effort. And until you've got massive scale, it just doesn't make sense to try to do it all yourself or try to bring it all in-house. Outside of marketplaces, the other sort of operating model is the resellers. So like HydraHost, Shadeform, FluidStack, like these are all big players out in the market that, will have customers ask them for infrastructure, and then they'll go out to, all the data centers and basically try to source it. Those deals typically, you're looking at like a 7.5 to a 15% margin in most cases. So they take a lower commission, but that's because, these are like, 1 year, 2 year committed contracts for millions of dollars. And so like, it's not like the on-demand workload that you see on the marketplaces. And then, the last thing is obviously selling directly to customers. If you've got them, like that is also very valuable. And that's where having a really strong operations in place is important, right? Like if you've got a customer on for a couple days or like a month or whatever, and then they stop, like you need to be able to very easily, decommission that machine and redeploy an operating system and keep track of where that machine is in inventory. Last thing that we'll talk about today is financing. Obviously, you could put up your own money and buy a lot of this stuff. And I recommend you do that to get started. But, after you get revenue coming in, after you've got operations around all this thing, there's a lot of money to be, borrowed, I guess. And there's a lot of, banks and investors that want exposure to AI infrastructure. And so you can raise money from them. And the thing that they're looking for right now is they've gotten a lot stricter. Before, they would finance just on your typical, cash flows. And that could be, on-demand customers from marketplaces. That could be monthly contracts. If you're making, whatever, like $200K a month, it all counted, right? Now, financiers are only looking to finance things that are on long-term commits. So this is like your 1 and your 2 year commitments from customers with really, really strong credit scores. I think there's a lot of players that got burnt on this where they borrowed way too much money way too quickly. Market takes a dip, stuff is unutilized, and they're not making their payments back to their financiers. So that world has gotten a lot tighter. I can't say I know a ton about it, or I don't have any firsthand experience doing any of those large deals, but at the very top end of the market, when you're talking about like the enterprise equipment, they're looking for, providers that have, consistent operations, and they know they can deliver on long-term contracts over multiple years. So if your goal is to get massive, I think going into it with that context that like, those long-term commits are worth a lot more than just short-term revenue, I think that's very important. But obviously, I think way down the road for a lot of people. I hope this wasn't too long. I'd love to actually know if anyone made it to the end of this video. But I will do, much more in-depth videos on each of these topics, right? Like, I'd love to assemble, or at least I've got some parts around, like we can build that motherboard, show everything connects. I've got one of those chassis. I'll show you how we like laid the GPUs out inside it. And then maybe I can get some pricing and stuff out of vendors on, like how much does it just cost to buy one of these. So that's the plan. I hope you enjoyed this, and I really appreciate it if you watched all the way through.